Hello everyone, welcome to a video tutorial learning about vertical shifts of exponential functions. What we're talking about vertical shifts are moving our function up or down on the graph and understanding how the graph and the equation that represents the graph go hand in hand together. So to start off with, to understand vertical shifts, we're going to take a look at this function here. F of x equals 1 times 2 to the x power. It's really simple one. But again, we're just trying to understand what's happening with the vertical shift. So let's pick some x values. Go x is 1, 2, 3, and 4, starting with 0. And let's quickly calculate when I put these x values in, what function values do I get back? So 1 times 2 to the 0th power is going to be 1 times 0, or 1 times 1. It's going to be 1. If I put a 1 in there, it's 1 times 2, so it's 2. If I put a 2 in for x, it's 1 times 2 squared, which is 4. 1 times 2 to the third is going to be 8. And 1 times 2 to the fourth is going to be 16. But here's where I want to have some fun. What if I take this function and make it a new function? Let's take it, we're going to call it g of x. We're going to take the same function, 1 times 2 to the x power. We're going to add 1. Well, now what do I get when I use these same x values? If I put 0 in for x, I get 1 times 2 to the 0th power, which is 1. So 1 times 1 is 1, plus 1 makes it 2. So for g of x, if I input 0, I get back 2. If I put in 1, so 1 times 2 to the first power is 2, plus 1 more gives me 3. If I put in 2, 1 times 2 to the second power is 4, plus 1 gives me 5. And hopefully you start to see the pattern that every function value for g of x is just 1 more than what we had for f of x because we added 1. We took essentially f of x and just added 1 to the end. So we see this whole plus 1, plus 1, plus 1, plus 1. And that's where we get at the heart of vertical shifts. If I was to plot this, point 0, 2 is going to be 1 higher than the point 0, 1. 1, 3 is 1 higher than 1, 2. And so by adding this little plus 1, I'm raising my whole function graph up 1 unit everywhere. All right, so verbally I'm describing that. We looked at a table. I think it'll make most sense to actually look at a graph. I'm going to pull up, I love using desmos.com. They have a great online calculator that you can use where you can put in functions, see the graphs, get a table of values, and really quickly help you understand all the math that you're doing. So I'm going to pull up a Desmos calculator here, and then we're going to explore more about vertical shifts with exponential functions and make a little bit better sense visually. All right, here we got it pulled up. You can see we got our same function. There's f of x equals 1 times 2 to the x power. And I added this little plus k at the end because then it gives us a little slider that we can play around with. And look at that. As I move k around, I can see that it makes my graph move up or down. To help even understand a little bit better, I'm going to add this point right here, which is my y-intercept. And if I set k at 0, you can see that the value for 1 matches exactly with our y-intercept, a y value for 1. Okay, so now let's play around with this function. We're going to pick some different values for k and just really make sense of what's happening here. So I'm going to make k 2 to start off with. So instead of adding 1 like we did earlier, now we're adding 2 to the function. And look at what happened. It went from 0, 1 up to 0, 3. For all these other points, the whole entire function moved up 2 units. If I move it up 1 more, if I make k 3, now it moves up from 0, 1 to 0, 4. So it went up 3 units. So whatever we add to the function exactly corresponds with a shift upwards. Remember when we talked about end behavior and before my function would tend to get really close to 0? Well, now because I've added 3 on the end, it's going to get really close to 3. Look at that as I'm getting moving my dot along there, it gets 3.003, 3.001. It's going to get really close to 3. Now it's starting to round it, but it's going to stay right at that line. There's an asymptote now at a y value of 3 because I moved the whole function up 3. All right, well, let's move it down negative now. Instead of k being 3, let's make it negative 3. All right, now look at what's happened. My y-intercept is at negative 2, so it went from positive 1 down 3 units this time to negative 2. And my horizontal asymptote, now it's getting really close to negative 3 because I've subtracted 3 from the entire function. Negative 2.9999, it's going to keep getting really close to negative 3, but never exactly reach negative 3. But there you go, that's the power of the vertical shift. I can have control now over taking my function and moving it up or down simply just by adding or subtracting a value to the end of my function.